Good morning, children. This is the class for your rapid revision on chapter matter. So in the first video, we have discussed about the matter, the atom, the smallest particle of matter that exhibits all its properties is called an atom. In the first video, we have discussed. In the same video, we have also discussed about the molecule, and the molecule has the independent existence, but atom don't have any independent existence. Next, kinetic theory of matter. In the first video we have discussed about these postulates. The main postulates of kinetic molecular theory of matter are: number one, all matters are composed of small particles, atoms and molecules. We have discussed this one just now and also in the first video. Molecules of substances are alike in all respects. The molecules of substances are in continuous random motion and therefore they possess kinetic energy. The intermolecular space we have also discussed. The molecules of substance have spaces between them. Molecules of substance are attracted towards each other and these are known as intermolecular force of attractions. And these force of attractions depends on two factors: intermolecular space and nature of molecule. In the first video we have discussed this one. This nature of molecules, the molecules of similar type exerts a force of cohesion and molecules of different type exerts force of adhesion. Kinetic energy, denoted by half of mv square, is directly proportional to temperature T, and kinetic energy is the energy possessed by a body by virtue of its motion. Next, in the first video we have discussed about states of matter, three states, and these three states are dependent on three basic factors: intermolecular space, intermolecular force of attraction, and kinetic molecular theory of matter. Solids, look at this figure 1.2a, arrangement of molecules in solid: least intermolecular space, intermediate intermolecular space available for liquid, and most intermolecular space available for the gas molecules. Maximum intermolecular force of attraction for solid because of this closely packed structure. Intermediate intermolecular force of attraction exists between the molecules of the liquids, and least attractive force, the negligible attractive force, exhibits in gaseous states. In the next video we have discussed about the change of matter, the state of matter, the change of state of matter, and the change of a substance from one physical state to another is called change of state. And there are several terms related to the change of state of matter. Completely we have discussed in second video for class 8. Melting, the process of change of substance from one solid into the liquid state at a fixed temperature is called melting, and the fixed temperature is known as melting point. Boiling, the process of liquid into its vapor state at fixed temperature. This at fixed temperature is your keyword, and this fixed temperature is known as boiling point. Next, condensation, from vapor to liquid. Freezing, from liquid to solid. Sublimation, from solid directly to vapor without passing through the liquid state. Deposition, the reverse of sublimation. And this figure 1.3, change of state, different procedures are there. In the last video for class 8, law of conservation of mass, we have described this one. It states that the mass can neither be created nor destroyed. The mass of substance remains same during the change. The total mass remains conserved in any physical or chemical changes. We have cited an example for the ice cube. In SCI vocab, there is a definitions of sublimation. Most important, solid directly changes to the vapor without passing through the liquid state at all temperature. These are your keywords. And check your progress, choose the correct option. The process of change of ice into water is change of ice into water, that means solid to liquid melting. The kinetic energy of gas molecules is maximum. Energy of the gas molecules is maximum for the case of the gas, because least intermolecular force of attraction. In the last video, for law of conservation of mass made for class 8, we have described that to verify the law of conservation of mass, we have described barium chloride solutions, sodium sulfate, conical flux, test tube, measuring cylinder, a cork, and wing balance. This is the whole setup for the experiment. This is your conical, this is your measuring cylinder, not given here. Conical flask, this is your conical flask, cork, sodium sulfate solutions, barium chloride solutions. We have described all this activity. Take 10 ml of barium chloride solutions in the measuring cylinder and pour into the conical flux. This is the 10 milliliter of barium chloride solution. 10 milliliter. Take 10 milliliter of sodium sulfate solution in the measuring cylinder and pour it in the test tube. Look at this. This is the sodium sulfate aqueous solutions, and you have to insert this test tube very carefully. Keep the test tube inside the conical flux carefully. Make sure that two solutions do not mix. And after that, you have to tilt the flask. You have to tilt the flux so that sodium sulfate and barium chloride reacts to form barium sulfate as a white precipitate. And the reactions, barium chloride when react with sodium sulfate, it will form barium sulfate and sodium chloride. You have to measure the total weight initially and finally. Initially the weight will be 200.22 gram. Look at this. And arbitrarily the same mass, 200.22 gram. Now barium sulfate formed as a white precipitate. Look at this. To form a white precipitate of barium sulfate, and sodium chloride remains in the solution. We come at the end of this chapter. This is the frame of questions on the topic learned so far. You can put these questions in the comment box. These are the page for your rapid revisions. And I'm going to show the video regarding the reactions of sodium sulfate and barium chloride. This is your sodium sulfate anhydrous. This is your barium chloride. This is a beaker, test tubes rack. Okay, these are the solutions we have to prepare. This is your sodium sulfate solutions. We are keeping the sodium sulfate solutions here. And this is your barium chloride solution. Now we are going to mix this one. These two are the clear solutions. As far we have discussed that we have to take 10 ml, though it is a qualitative measurements, but equal volume it should be mixed. Now we are going to add this one, sodium sulfate, and look at this, there is a clear solution. Now the white precipitate comes just contact, and these reactions is the double decomposition reaction. So this is the total experiment. The next video we'll discuss about that question answer zone.